table gives values for a function g at selected values of x. Which of the following statements is true? So it looks like it wants us to talk about linear, quadratic, linear, quadratic. So this is what I have to do. I have to make sure that the x values go up by the same number every time, and they go up by 2. Now, usually when they see these, they go up by 1. But in this case, with this problem, I had them go up by 2 because just like 2 chains, I'm different. Now, what we're looking for over here is to see the first order of rates of change. That gives us whether or not this is linear. If the rate of change is constant throughout, it's a linear function. So what do we do to get from 8 to 9 to 8 to 5 to 0? Well, I'll tell you one thing. It ain't linear. We add 1, we subtract 1. We subtract 3, we subtract 5. It's not linear. So it's not linear, which means no to you and no to you. A and C are not an option. Now, to test to see if it's quadratic, we need to see if the rate of change is constant. So what happens here? Well, from 1 to -1, you subtract 2. And from -1 to -3, you subtract 2. And from -3 to -5, you subtract 2. So this is quadratic. This is quadratic. And it's quadratic because the second differences of the output values over equal interval input values are constant. Now, it's D, but if you're looking at two phrases that you don't like, here's phrase number 1. Equal interval input values. That is these guys. Since these guys change the same exact amount of numbers, or it's added to every single time, that is the definition of equal interval input values. Okay? And that's constant. Thing number 2 that we care about is the successive second differences of the output values. Some problems might word it as the rates of change of the rate of change or the second rate of change. Either way, it's going to be this guy because it's the second differences and not the first. The first differences would make it linear. So the answer is D, and hopefully I explained these well enough with minor stuttering. For, again, equal length, I can never say this correct. Equal interval input value lengths is very difficult to say. Say it twice, 5 times. I dare you. I'll give you a second. See, I told you couldn't do it. Hope this helps.